All right, so we're going to look at example one here, and example one is an exponential equation. An exponential equation is something where the thing that we're trying to find, or the x or the variable, is in the exponent. So I'm trying to find this x, but there's also an x over here. So again, thinking about your strategies to solving equations, we can think of an algebraic way, which we'll show. We can try kind of a trial and error guess and check. We could maybe try to graph or use the table feature of our calculator. The strategy that we're going to try here is trying to make the bases the same. This is a situation where we have two powers that are equal to one another, meaning if I have basically if I have the same base, let's say I have b to the x equals b to the y. Right? If I have two powers that are the same base, they both are b, well then it makes sense that the tops, these exponents, have to be equal. So I can say x equals y. Right? Like for example, if I said, let's see, if I use the base 5, and I said 5 to the 2 equals, it's kind of a silly example, but 5 to the x, and I said, well, what does x have to be here? Well, it's pretty clear that x would have to be 2 there. It has to be. There's no other option. So our strategy here is, if possible, can I make these bases the same? Right now they're not the same. One of them's 3, and the other base is 1/9. So can I rewrite one of these bases so that it's like the other one? And the answer is yes, you can do that. In this case, if I have 1/9, right, how can I write that as a base of 3? Right? Is that possible? And the answer is yes, you can do that. Because if you think about 1/9, I could write 1/9 as 1 over 3 squared, which is getting closer. And I can write 1 over 3 squared as 3 raised to a -2. So actually, 1/9 and 3 to the -2, those are the same exact thing. Those are equivalent values. So what I'll do here in this problem is just rewrite it with the same base. So 1/9 I'm going to substitute. Instead of 1/9, I'm going to put 3, not -3, 3 to the -2 there. And that still is raised to the x plus 3. All right, so another thing that we have to do here is use our exponent properties. So to clean this up on the right-hand side, I have -3 to the -2, but that's raised to the x plus 3. Well, what do we know about exponent properties? When I take an exponent and I raise it to something else, I'm going to multiply those things together. So I'm going to write this as 3 to the x is equal to 3 to the, and I have to multiply -2 times x plus 3. I have to multiply those things. So if I multiply them, I would just say that's -2x minus 6, right? So this becomes a -2x minus 6. So now this is the situation where now I have the base is the same on the left and right hand side. So since the base is the same on the left and the right hand side, I can set the exponents equal to one another. So I'll put those in red, and that has to mean that x, I'm just going to kind of ditch the bases here, x has to be the same thing as -2x minus 6. They have to be equal. Well, once I do that, then it becomes an easy problem to solve, because now I have a linear type of problem, and I can go ahead and do my algebra with this. So if I add 2x to both sides, then I get 3x is equal to -6, and I can divide by 3 and get x is -2. And there's my answer. All right, so here's another practice problem. You can go ahead and give it a try, pause it, or if you're still a little uneasy on it, then you can just work it with me. So again, I have 5 to the 2x plus 2 equals 625 raised to the x minus 1. So this is an exponential equation. We're trying to solve for x, but x is in the exponent. And we're going to try to use that strategy again of, can we somehow rewrite these bases so that they're the same base. Right now we have 5 and 625. So 625. The question really is 625 some kind of power of 5? Can I write 625 as 5 to the something? And the answer is yes, you can. It's kind of set up that way. So 5 to the 4th is equal to 625. So I'm going to make that substitution and say 5 to the 2x plus 2 is equal to 5 to the 4th raised to the x minus 1. Now I'm going to clean up this right hand side because now I have exponent of 4 that's raised to another exponent of x minus 1. So since those are next to each other, I need to multiply those using my exponent properties. So what's 4 times x minus 1? Well, that's 4x minus 4. Okay, so now my problem becomes 5 to the 2x plus 2 equals 5 to the 4x minus 4. Now we've done that job. We have written this as the same base on the left and the right hand side. So therefore, these exponents have to be equal. There's no other way around it. So we can just write that as 2x plus 2. That has to equal 4x minus 4. From here, this should be easy. We're going to get the x's together and get the constants together as well. So let's do that. I'm going to bring my x's over here. I'm going to subtract the 2x. That's going to leave 2 equals 2x minus 4. Then I'm going to bring the number to the other side. I'm going to go ahead and add 4 to both sides. That's going to give me 6 equals 2x. And then finally divide everything by 2 to get x equals 3 in this case. All right, so let's look at another example. In this case, we have an exponential equation. 9 raised to the x equals 35. And the strategy that we used in the last couple problems was to think about can we write both sides of the equation, both of those expressions, as powers of the same base. Because if we can do that, we can kind of just set those exponents equal and it becomes pretty straightforward. But what if you have a problem that you clearly can't do that? So 9 and 35 here. Is there a way to write this? So like 9 raised to the x, can I write this as 9 raised, what's 30? 9 raised to the what is 35? And you think about your integers, 9 squared is already 81, and basically you're not going to be able to figure that out unless you just do a bunch of number crunching and trial and error and maybe kind of get close. A logarithm is going to help us figure this out. So I'm just going to take this problem that's written as in kind of an exponential form, and I'm going to rewrite it in log form. Rewrite that in log form. So how am I going to do that? All right, so if I'm going to rewrite this in log form, I'm actually going to have a function, log, and I'm going to have an equal sign. I'm going to think about what's my base here. The base of the equation above is 9, so I'm going to have log with a base of 9, and my exponent is x. That's going to be on the right hand side. The number that I'm getting, my output, is 35. So I'm going to rewrite this like this. Right, so we're just using the definition of what a logarithm is to rewrite this exponential equation, write it as a log equation. And we're just thinking about what the definition of what we learned a log is. So again, these are equivalent equations right here. And I'm just rewriting them. Because remember, a logarithm is actually an exponent. So if we can figure out what this is right here, x is actually equal to log base 9 of 35. Now, the thing that we're going to do here is use a calculator to figure this out. So if you grab your calculator, there are a couple ways to do this. First of all, if you have a graphing calculator, you can go to Math, and if you go over to, let's see here, if you go to down in the Math menu, you may have a log base function. The log base function on the calculator just allows you to type in both inputs for your logarithm, so it kind of has a really nice interface, a nice setup. If I click on that or press it, notice that we have a log that I can type in both the base and the number here. So if I want to figure out what is log base 9 of 35, I can say, well, type in the base 9 and 35, and I can ask the calculator what that is, and it's going to be some approximate answer, in this case 1.618. So since this is an approximate answer now, I'm going to say x is approximately 1.618. Now, if you don't have that, button on your calculator where you can use that log base button, you can also, and we skipped over this section due to time, if you just have a common log button, you can rewrite this, or you can use a calculator like so. So if I'm trying to figure out what that is, I can just use the normal log button or the log base 10 button and just say, let's take log of 35, or log of the big number, divided by log of the small number, which is the base of 9. And that also will give me an answer. So back to my calculator. If I don't have that log base button, and I could just grab any scientific calculator, I could just use my common log button right there, right on the front of the calculator. And I could say, well, what's log 35 divided by log of 9? And that should be equivalent to what I wrote up here in my calculator. It's actually the same thing. You can see I get the same answer, 1.618. The cool thing is, if you use any logarithm with any base, the same thing would happen. So even if you use the log button down here, the ln button, which is still a log, if I use ln there and did the same thing, 35 divided by ln of 9, I would get the same thing. So really, you can evaluate these log expressions if you have any calculator. And so you're going to do it like that. So we didn't go over the last section on these little properties here, on how that actually works. We'll come back to that if we have time, but your answer there is 1.618. All right, let's try another one. So we have an exponential equation here. I'm not going to go ahead and try to make these bases the same. I'm just going to rewrite this in log form again. So I'm going to rewrite this as, this is the log with, I have a base of 4 here, so I'm going to have base of 4 here. Log base 4 of 4d equals x. And again, that essentially solves my equation. I have x by itself. I just need to figure out what is log base 4 of 4d. In other words, 4 to the what is 40. I can get to that answer quickly by going to my calculator and using the log base button, or using the other methods that we used before. So what is the log base 4 of 40? Let's go ahead and you type that in. 2.661 approximately. Again, if I didn't have the log base button and I just have any log button, I could say, what's the log of 40 divided by the log of 4, and that would be the same thing, 2.661. So my answer here is approximately 2.661. All right, let's try another one. So same thing, we have an exponential equation because we're trying to solve for x, and then that's inside of an exponent, or is an exponent. And so we're going to use the same strategy here. We're going to just rewrite this in log form. But before we attempt to do that, we're going to get our power. We're going to get our power with the exponent there. Get that by itself. So there's one extra step here. Right? I have this plus 3 that I can easily kind of get rid of. I'm going to subtract 3 first from the problem just to get it to the other side and combine it with 100. So now I have 5 raised to the x plus 2, but that equals 97. All right, and this is what I'm looking for. So now I just have a exponential equation, and I'm going to rewrite that in log form. So I'm going to have log with a base of, my base up here is 5. My number, or my value on the right hand side, is 97. That's going to go here. And on the right hand side I have this exponent of x plus 2. So this is going to be right here. X plus 2 is going to be on the right hand side. So this is the log form of that, right? Okay, so now all I'm going to do is try to get rid of, or get x by itself. So here's my x, and I want to get that by itself. So to get rid of, or to get that by itself, I'm going to subtract 2 from both sides. So now I have x is equal to whatever the log base 5 of 97 is. I'm going to keep that like that for now. And then subtract 2, well, that's going to be my x. Now the thing that I don't know is, or what I have to approximate, is the log base 5 of 97. So this is where we're going to ask the calculator to figure that out for us and approximate a value there for us. So what is the log base 5 of 97? Let's go ahead and ask the calculator for that. Log base 5 of 97 is approximately 2.842. 2.842. So this is 2.842. 842, and then subtract 2, which is equal to x. So 2.842 minus 2 is just going to be about 0.842. This is approximately that, not exact, but about 0.842. Again, if you're looking at this and saying, hey, I don't have that log base button, if you have any calculator at all, you can do that just by using the normal log button and going log 97 divided by log of 5, and that is still 2.842. One last option here, if you, you can use Google, you can use, I'm just bringing up Desmos here, just in case I get someone who says, I didn't have a calculator that didn't have a log button, or that had a log button, or I didn't have my calculator, I only had my Chromebook. You can go to Desmos, and you can just type in the same thing. So if I don't know what log base 5 of 97 is, I could say log of 97 divided by log of 5. And you can see it's going to tell me the answer right there, 2.842. All right, so that's it for solving exponential equations. Again, just to review, if you have a problem or problems that if you can write these bases as the same base, then that's a strategy that you can use to solve the problem. That's what we did in the first couple. But if you can't do that, then you either have to use kind of trial and error, or what you want to do here is use a logarithm. Rewrite in log form so that you can get your answer. And then the last problem that we did, if you need to add or subtract or get this power by itself before you write in log form, then make sure you do that as well.